Okay. So, hello guys, welcome to today's post-contest discussion. Right, we'll be covering problems A to F, and let's start with A. So, recovering a small string. Now, what does this problem statement say? That we have to make a string of size 3, and the sum is given to us. Like whatever the sum of the letters is, they are indexed and they are given to us. We are told that we have to find the smallest string that satisfies it. Okay, so let's move on to the tab and try to understand how to solve this problem. So yeah, so what are we given? A is denoted as 1, B is denoted as 2, so on and so forth. We know that there are 3 characters in the string, exactly 3 characters. Okay, and we have to find the minimum string. Okay, minimum string such that whatever value you choose, for example, let's say it was ABC, then whatever values it corresponds to, okay, V of A plus V of B plus V of C is equal to, V is basically value, is equal to the sum that we are given. So here, and the thing is, it will always satisfy because the numbers here are from 1 to 26. Okay, and 26 into 3 is 78, and since we are always given this and it's always smaller than equal to 3 as well, so the smallest string that is possible AAA and the largest string that is possible ZZZ is within the constraint, so we don't need to check if it is possible or not possible. So the idea in this problem is very simple. Before this, what do we have in hand? Is that much clear? Like, is this much clear that what the problem asks and why we don't need to check if it is possible or not possible? Do drop a yes in the chat if you guys, yeah. So our idea is very simple. Let's say we will start fixing the characters from left to right, okay? Because we want to make the lexicographically smallest string, right? And what does it mean to make the lexicographically smallest string? You start with the first character, because in ABC and BAA, this one is the smaller one. Now, what do we have to do here? We have to fix the smallest character such that I can allot the other values. I can allot some characters to the other values. What do I mean by this? For example, I have 53. Okay. So if I try to fix A here, okay, what is the value of A? The value of A is 1. So if I subtract 1 from 53, I will get 52. Now, can I allot 2 characters here such that the sum is equal to 52? I can, right? I can allot a Z here and I can allot a Z here. Basically, how many ever characters are remaining, okay, that into 26, if the sum is smaller than equal to that into 26, for example, there are 2 characters remaining here, and so if 52 is smaller than equal to 2 into 26, I can say that, okay, this is A is now possible. And then I just fix A, because why will I not go to B? Because A is smaller than B. So I will say that, okay, the first character has to be A. Then I will go to the second character. Similarly, for 52 in this case, you can't really take anything apart from Z, but let's see, okay. While we are trying to fix this, let's say we try to fix B, okay. So our sum is 52. I subtract 2 because the value of B was 2. And then 50 is left. Now, how many characters are left on the right? There is 1 character left on the right. So is 50 smaller than equal to 1 into 26? No, it is not. So I cannot take 50. But can I take Z? If I have to take Z, what is the value that is left? 52 minus 26. So 26 is left. Is 26 smaller than equal to 1 into 26? Yes. It means that in the second character, I can take Z, then I move on to the third character, and that is what it is. So is this much clear, guys? Is the condition clear that we are trying to fix a character? Okay. Fix the character from left to right. Okay. And when we are trying to fix a character, we go towards, like, let's say there are X characters on the right. Okay, whatever index you are, there are X characters on the right. Then what condition do we want? The remaining sum should be smaller than equal to X into 26. This is the condition we have to satisfy. Guys, does it make sense? You could have brute forced this problem as well. Like you could have just run a for loop, but this is a mathematical approach that I'm trying to teach you guys so that you can think mathematically. Is this much clear, guys? Tell me. Tell me, guys. Drop a yes in the chat if you guys
Can you
can
explain
answer.
again the remaining part, the last
Sure,
part?
sure, sure. For example, um, let's say I am trying to, this has already been fixed. The sum left is 50. Okay. The sum left is 50 and I'm trying to fix what this character is. Now, if I try to put a B here, okay, how much value will it decrease? It will decrease the value by 2. Okay, and 48. What is the largest sum I can make from the, like if I had to put any characters here, is it possible to make it using sum 48? Since the characters only lie from 1 to 26, the largest string I can make is how many our characters are here into 26, right? So currently there is one character. So 1 into 26 is not 1 into 26 is the maximum sum that is possible. And 48 is greater than 26. So it is not really possible. Then what is possible? I have 50, right? So I will just subtract 26 from this. So it's 24. And 24 is basically X, if I'm not wrong, right? So this is the smallest string that is possible if it was uh, 51, right? Is this much clear?
Yes.
Who? Great. So if this much is clear, I'll just show you the code, right? I have written a very mathematical kind of code. Let's just ignore it. There are a lot of implementations. So basically, you could run a for loop as well. But when you're trying to fix the first character, then the maximum sum that you can make using the other two characters is 52. So x maximum of x minus 52 comma 1, right? Basically, you can start from a and then so on and so forth. And then once you fix the first character, the remaining sum you have is x minus first, and then on the right hand side you can fix only one z, so minus 26 there, and in the end third is just x minus first comma second, right? So it's the same thing that I'm doing, just in a little bit complicated way. You could just run a for loop and do the same thing. So is problem A clear, guys? Tell me. You could have brute force. That was the point of this problem. The intended solution is brute force, but I'm doing it in O of 1. Okay. So if this much is clear, let's move on to the problem, make equal. Let's see what this problem asks. There are n containers of water lineup numbered from left to right. Okay. So what does this problem statement say? That okay, I hope I remember correctly. Yeah. So what does this problem statement say? There are n water containers, okay? And you can pour water from any container to any container to its right, okay? So I cannot, keep in mind that I cannot do it backward, but I can only do it forward. Now, each container contains some water AI in it, okay? What is our job? Our job is to make water in all containers equal. Okay. So and also it is given that the sum is divisible by the number of containers, right? So by this statement itself, like here it is given, right? The sum of AI is divisible by n. So the first thing that comes to mind is, if I have water, I know how much water is there,
What
and
is
I
the
want to
meaning of it? Sum of AI divisible by n?
basically the sum of the array is divisible by the number of containers.
Okay.
Sum of array basic. So I'll tell you, right? So let's say I know the total number of water, right? Let it be capital W. So in each container, how much water should go? It should be W divided by N, right? Now, if W is not divisible by N, this will give us some decimal value. So that is why in the problem statement, it is given that sum of AI is divisible by N. Basically, W is divisible by N. So what do we know?
Okay.
This is the water in each container. Okay. This is the first observation. Now, I want to ask you a second observation. Okay. Let's say you are on the first container. Do you guys agree that the water in the first container can only decrease? It can never increase, right? Tell me, guys. Can the water in the first container increase? Can you put, like, let's say there is water like this, okay? Can you put water in this container from any container to the right? You cannot, right? You can't. So, you want to make this container's water W by N, okay? So, let's say the water is smaller than W by N, then you just discard it. It's not possible. Otherwise, there will be some excess. Okay, let this be X. So I will just transfer this X amount of water in the next container. No, wouldn't it be optimal? Like, think about it. Because this whatever water is there, it can go anywhere. So I'll just put it in X. I'll just put it in the next container and then just solve it again for this. Does it make sense? For example, let's say each container had to have water 3. And let's say the water levels are 5. Here it is 2, and here it is 2. Okay. So there cannot be, you can't put water here. So I'll just make this 3, and there is extra 2 left. So I'll just put this 2 here. Now the water here is 4, but we need only 3, right? So again, I'll just take the excess, which was 1, and I'll put it here. Now each container has 3, 3, 3. So can you guys find the pattern? The pattern here is that just iterate from left to right and pour the excess water in the adjacent container. Pour excess water in next container. And if the water in the container is smaller than W divided by N, then it's just not possible when we are coming at a particular container. Is this much clear, guys? Tell me, guys, is this much clear? Do you have any doubts?
Why it should be exactly W by N? It's just
Because
it should be a divisor of N, right? A divisor of W, right?
okay, so I'll tell you. First, we cannot waste water. Okay, very important. We cannot waste water. So what you are saying that summation AI is going to be constant, or basically capital W. If in the start there is capital W water, then in the end also there is capital W water. Now if you have to, now if the water is constant, and if you want to give equal water to each, like if there is 10 candies and there are 5 people, and if you want to give equal number of candies to each person, how much candies does each person get? It's 10 divided by 5, right? Can you give, so that's 2. Can you give one candy to each person and then just say that uh call it a day? You have to utilize the entire candy bag. Does it make sense?
But don't you think it should be summation of a n minus 1?
Why -1?
A n minus 1. Because summation of
Why
all elements. Because AI is like a index value of some particular element.
Yeah, that's fine, right? If you're talking in one based indexing, it's 1 to n. If you're talking in zero based indexing, it's 0 to n minus 1. That is, you understand the basic concept, right?
Yeah.
Yeah. So who asked the doubt that it should be divisor? Is that clear? Do let me know if it is not clear. But in general, if the water is fixed and you have to give the entire water, okay, so how much does each container get? It's W by N, right?
Yes, W by N. Yeah.
Yes.
But I am
So
saying
that
why
is
it should be exactly W by N. Why it cannot be anything else? We will distribute the water equally. We will not waste it. But why it should be W by N only? Why not any other?
because W by N into N is W. If each person gets W by N and there are N people, cancel it, the water remains the same. If you give anything else, okay, let's say you wanted to give divided by anything, okay, N divided by 2. This does not stand, right?
No. I am saying suppose if we have W equal to 10 and we are dividing into 2. So according to you, it is 5 and 5 to 2 people. But I am saying why it cannot be 4, 2 and 8 or something like that.
The
3 and
problem asks that water, each container should have the same amount of water, no?
yeah.
Yeah, so it should be 5 and 5, no? It cannot be 2 and 8. That is what the question asks. The question is asking us if it is possible to make all the containers. So I guess
Okay.
misread the problem. So is the approach clear, guys? Put a yes in the chat if the approach is clear. What was the approach? We iterate from left to right and we pour the excess water. Like if there is excess water in the current container, we put it in the adjacent container. Because let's say if I want to pour water from container 1 to container 3, it's the same as pouring water from container 1 to container 2 to container 3, right? So I will just iterate from left to right, basically from 0 to n minus 1. And I know the current water. If the current water is smaller than W by N, it means that I cannot increase it because I've already processed everything on the left. Okay. Now, if the current amount of water is smaller than W by N, it's not possible. Otherwise, what do I do? Whatever excess water is left, I just pour it in the next container. If the approach is clear, please put a yes in the chat. and I will show you the code right now. So the code is very, very small, right? So initially I have two variables, OK and extra. Extra means the amount of water that is extra right now, and OK means if it is 1, it means that it is possible. If it is 0, it is not possible. So I take an input, and then how much should every element get? It's sum divided by n, right? So this is a inbuilt function that gives you sum. And after this, as we discussed, if I plus extra is the amount of water in the current container. If I plus extra is smaller than per element, then OK is 0, basically stating that it's not possible. Otherwise, extra is how much? The amount of water in the current container minus how much the current container gets. In the end, if it is OK, I'll print yes, otherwise no. Some of you might tell me I also have to check that extra is equal to 0, but it is not really a necessary condition. This much is more than enough. Like, it doesn't really matter. So tell me, guys, is this clear? I'm
What
not
does
sure.
that mean? 0 LL?
Long. 0 in long. Rating of the question is around 1000. I guess I'm not sure. You can use ProbRat. I'm quite bad at predicting ratings of problems, right? So moving on to the next question, right? Make equal again. So you have an array of n integers. You can apply this operation no more than once. What does this mean? You can either apply this operation 0 times, or you can apply this operation 1 time. Now, what does the problem say? Yeah, we will be discussing F, not G. So what does this problem say? That select three integers I and j, and x, and set the entire range from ai to aj to elements x. Basically, what does the problem say? That if I have an array 1, 2, 3, 4, 5, okay, I select a range. Let's say I select this range. So starts at index 2 to index 4. I'm using one based indexing. It's not really necessary. Okay. Then I set all elements in this range to anything that I want. I can set it to 1, I can set it to 2, I can set it to 3. Right. So, and the cost of this, okay? The cost of this is the length of the subarray I chose. Okay. So this is what the problem statement says. I can do this at most one time. Select any subarray and then put all the elements to whatever you like. Okay. All of them, either you can put it to 1, 1, 1 or 2, 2, 2 or any value x, x, x. And the cost of this is the length of the array chosen. What are we asked? What is the min cost to make all elements equal? So the first observation is that if all elements are different, okay, like I'm not talking about that this is the answer. I could have just selected the entire array and made it into whatever x, 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 x. So it is always possible. First thing, always possible. But is this optimal? Like, how do I try to reduce this length? Now, if all elements are equal, okay, all elements are different, 1, 2, 3, 4, 5. You can see that instead of selecting the entire array, I can either select this range or I can select this range and make it equal to the first element or the last element. If I'm selecting this range, I will make all elements equal to 5. If I'm selecting this range, I will make all elements equal to 1. Is this much clear, guys? Tell me. Great. So if this much is clear, let's move on. Now, what is another observation? Another observation is that if you have an array and you choose any subarray, okay, then some amount of prefix and some amount of suffix is bound to be left. And this is the only thing that remains. You choose anything, okay? You choose this subarray, then this suffix will be left, this prefix will be left. You choose this subarray, this prefix will be left, this suffix will be left. Okay, and let's say I choose an arbitrary range. Okay, I select this range. I want to make all these elements equal. Okay, and I'm not choosing this. So do you guys agree that if I have to make all these elements, all the elements in the array equal, then all these have to be equal? All these have to be equal, and this range I will make it to whatever this value was. So these values already have to be equal, and then this particular range I will make equal to this xx. I'll change it to xx. Is this much clear, guys? Great. So if this much is clear, what did we observe? Some amount of prefix has to be equal, some amount of suffix has to be equal. So if we think greedily, okay, we just find the size of the prefix such that all elements are equal. For example, if it's 1, 1, 2, 2, 3, 4, 5, then I will just say that the size of the prefix such that all elements is equal is 2. And I'll also find the size of the suffix such that all elements are equal. Now, there are two conditions. A0 is equal to an minus 1 or A0 not equal to an minus 1. Okay. What does it mean when A0 is equal to an minus 1? When A0 is equal to an minus 1, it means that the array is something like this. Okay. Then what do we do in this case? In this case, we know this prefix, we know this suffix length. Okay. Then how many elements do we need to change? Let's say this is x, this is y. We just need to change n minus x plus y elements. These many elements. Do you guys agree? Put a yes in the chat if you guys agree. If you have any doubt, please do let me know. Okay. So if you guys agree with this much, now what if A0 is not equal to an minus 1? If A0 is not equal to an minus 1, it means that we'll have to decide. For example, 1, 1, 2, 2, 2. Okay, this is the array. So in the suffix, I have 3 elements. In the prefix, I have 2 elements that are equal. Now, if I choose to make all elements equal to 1, let's say this is x, this is y, okay? Currently, it's 2 and 3 because 2 elements are equal, 3 elements are. So if I choose to make all elements equal to 1, I will have to make n minus x elements equal to 1. So the cost will be n minus x. But if I choose to make all elements equal to 2, then my cost will be n minus y. So whatever is min of both of these is what my answer is going to be. Is this much clear, guys? Yes, exactly. There are two possibilities. A0 is equal to an minus 1 and A0 not equal to n minus 1. Put a yes in the chat, guys, if this much is clear. Yes. Okay. So if this much is clear. Yeah.
Show the previous example, the last example.
Yeah. Tell me.
No, n minus x, n minus 1. The minimum of x comma y. That one. Yeah, this one. Yeah. So in between 1 and 2, if other elements are there, you have to consider that also, right?
Yeah. So that is why I'm taking n, right? N is the number of elements.
Okay.
So apart from this particular prefix, the entire, let's say 1, 1, 2, 3, 4, 5, 5, 5. Okay. How many elements are there? There are 7 elements, right? No, there are 8 elements. So n is equal to 8 here. So the prefix is 2, right? X is equal to 2. So if I decide to make all elements equal to 1, what is the cost? It is n minus 2, which is 8 minus 2, which is 6. And if you see, I'm changing 6 elements. But if I choose to make all elements equal to 5, y is equal to 3 here, because there are 3 elements equal in the suffix. So how many, what is the cost? It is n minus y, which is 8 minus 3, which is 5. And if you see, I'm changing 5 elements equal to 5. Does it make sense now?
Yes.
Great. So that is more or less it, right? That is the solution, right? Answer is int max. I have two iterators, left, right, left count, and right count. So while left is smaller than n and a left is a0, I'm doing left plus plus and left count plus plus. Basically, I'm counting in left count, it stores the elements equal in the prefix. You could use a for loop as well, but in the context, I used a while loop because it just felt more clean for me. And for the suffix, while right is greater than equal to 0, while a right is equal to a n minus 1, right minus minus, right count plus plus. So if a0 is equal to a n minus 1, see out max of a0 comma n minus left count plus right count. Why am I saying this? Because let's say if all elements are equal, then left count will also be n, right count will also be n. So this answer will come out to be negative, but that is wrong, right? So the answer can be a non-negative number. So that is a max of 0, comma n minus left count plus right count. Otherwise, if the first and last elements are not equal, I just print minimum of n minus left count, comma n minus right count. Is this much clear, guys? Tell me, is there any doubt? We are here to solve your doubts, right? We are here to eliminate them. So tell me, guys, are your doubts clear? Is there any doubt in this problem? Problem C. If not, we can move on to problem D. Someone put a yes in the chat. Great. So let's move on to problem D. Okay, divisible pairs. This is actually a very interesting sum. It's not really hard, but how to apply the problem, the standard problem to sum is what we are going to do here, right? So what does this ask?
What's the rating?
I'm pretty bad at that. I don't know. You couldn't. There's a Discord bot known as TLE. You could just use probrat command and it will give you the exact rating of the problem. Okay. So what does this problem statement say? Polycarp has two favorite integers, x and y. Okay. And he has found an array of length n. Polycarp considers a pair of indices beautiful if ai plus aj is divisible by x and ai minus aj is divisible by pi. Okay. So we want to know the number of beautiful pairs, right? So what is the number of beautiful pairs? It is said to be beautiful if ai plus aj is divisible by x, or basically mod x is equal to 0. Okay. And ai minus aj mod y is equal to 0. These are the two conditions that the pairs must satisfy if you want to call them beautiful. Is this much clear, guys? This is what the problem asks. So if we just observe these two equations, we will just come to know the solution. Okay, let's take an example. Let's say, let's solve this y thing first. Okay, AI minus AJ mod Y is equal to 0. What does this mean? That the difference is divisible by Y. I am exactly writing what is given in the problem statement. Okay. Now, if I just write this, okay, I will just, let's say, add AI on both sides. You can do that in modular arithmetic, or I'll add AJ on both sides. So AI minus AJ plus AJ mod Y is equal to AJ mod Y. Okay. Now, if you see these two cancel out, minus AJ plus AJ, what does this mean? AI mod Y is equal to AJ mod Y. Is this much clear, guys? What did I do? I just added plus AJ on both sides under modular arithmetic, right? So these two cancelled out and there is a AJ over here. And in the end, what does it show? AI mod Y is equal to AJ mod Y. This is the first condition. Okay. Is this much clear? Put a yes in the chat if this much is clear. Yes. Now, if this much is clear, let's move on to the second part. Okay. AI plus AJ mod X is equal to 0. Okay. Now we know that, okay, this is a modular arithmetic equation. A plus B mod M is same as A mod M plus B mod M, the whole mod M. Is this much clear? Is this equation clear? Take a minute to digest it. A plus B mod M is same as A mod M plus B mod M, the whole mod M. Okay. Put a yes in the chat if this much is clear. Okay. Okay. Now, if this much is clear, okay, what we basically have to do is AI mod X plus AJ mod X is equal to the whole mod X is equal to 0. So if I know AI mod X, do I know what AJ mod X should be? For example, let's say X is 5. Okay. And AI mod X is 0. So tell me, guys, what should AJ mod X be? What should AJ mod X be? Anyone? If I
Zero,
know
I
that
think.
0, in modular arithmetic, it's only from 0 to x minus 1, right? So if x is 5 and AI mod X is 0, then AJ mod X is also 0. Similarly, if AI is 1, AI mod X is 1, then AJ mod X will be 4, right? When you do something mod X, the values are from 0 to x minus 1. So if AI mod X is 1, AJ mod X has to be 4. If AI mod X is 2, AJ mod X has to be 3. And similarly, 3, 2, 4, 1, 0.
One small note, like, can you give some proof for that, like how A plus B modem will be A modem plus B modem whole modem?
Uh,
That thing.
I mean, it's just a general formula. I'll do one thing, okay? I'll share the link to our article later. Does that work?
Yeah, sounds good.
Okay. For now, just black box it, right? Just trust me when I say that this formula is there. Okay. Like, it is pretty logical to prove it, but like, I'll do it, or I'll just take this at the end. Okay. So is this much clear, guys? Tell me. Is this much clear? If I'll just, yeah. So if AI mod X is 0, AJ mod X has to be 0. If AI mod X is 1, AJ mod X has to be 4. AI mod X is 2, AJ mod X has to be 3. Exactly, is 0 or x minus AI mod x. It's either, so basically what this is x minus AI mod x, the whole mod x. When this was 0, 5 minus 0, the whole mod 5 gives 0. When this was 1, 5 minus 1, 4. 4 mod 5 give 4, and so on and so forth. So what did we come to know, guys? If I have AI, which AJ will satisfy these conditions? The ones such that AJ mod x is equal to x minus AI mod x, the whole mod x. And what is the other condition? AI mod y is equal to AJ, AJ mod y. Are these two conditions clear? Tell me, guys. Are these two conditions clear? So if these two conditions are clear, we can just apply two sum on it. If you don't know what two sum is basically like you just use a map to compute this in n log n. So what is our idea? If you don't know what two sum is, okay, if you have never solved two sum, our idea is this right here. If we want to do this by brute force, okay, we know the conditions. If you want to do it by brute force, it will be O of n square. So to bring it down to O of n log n, our idea is that we will store a map. And what will be the key be? It will be a pair where the pair will store AI mod x and AI mod y here. And what will be the value be? It will be the count of elements such that AI mod x is that and AI mod y is this. Okay. Now, when I'm iterating through the array, let's say I'm at a particular I and I've pre-computed some amount of prefix and I'm here. So what will I do? If I know AI, I know what AJ mod X should be, and I know what AJ mod Y should be from these two equations. Okay, I've just derived it. AY mod Y, AJ mod Y is equal to AI mod Y, and AJ mod X is equal to X minus AI mod X, the whole mod X. So I will just add what to my answer? I will do answer plus equal to, let's say this value is capital X and this value is capital Y, plus equal to M of X comma Y. Does this make sense, guys? Tell me. We are just going to use a simple map to store this in O of n log n. Is there any doubt in this? So the comparator for pairs is that the first. Can you repeat this thing once again? Okay. So I assume that you might be aware of the problem to some, but let's say you're not. So basically, if let's take an array, okay, 1 2 7 4 9 6. 1 2 7 4 9 6. I know this, that if I am on an I, what should AJ mod X be and what should AJ mod Y be? Okay. Currently, my map is empty. Okay. My map here, I'm storing a map. It is empty. I'm on 1. So AI, and what is X and Y? X and Y is given to be 5 and X is given to be 5, Y is given to be 2. Okay. So X is given to be 5, Y is given to be 2. So what is 1 mod 5? It is 1. And what is 1 mod 2? It is 1 again. So what should the values of aj mod x and ay mod x be? Aj mod y be. So aj mod y should be the same because here we have derived that formula. And what should aj mod x be? It should be x minus ai mod x, the whole mod x. So 5 minus 1 is 4 and 4 mod 5 is 4. So all values that satisfy 4, all values that are mod, when you mod it with x, you get 4 and not or, okay, and the value when modded with y will give you 1. That is the pairs you can pair it up with. Okay, currently there is none. In our map, there is none. So our answer is 0. Okay. And once this is done, I will just put this 1, 1 in my map. So currently for my key 1, 1, there is one value which satisfies it. Now I move on to 2. When I move on to 2, 2 mod 5 is 2 and 2 mod 2 is 0. So which values, like for which values will this be satisfied? Like for which values of aj will be satisfied? For all values where aj mod x is equal to 3 and aj mod y is equal to 0. Can I see anything in this map here such that 3, 0 exists? No, right? So the answer remains 0. And before moving on to the next index, I will just take 2, 0 and I will do it plus plus. So initially it was 0. So I'll put it as 1. Yeah. Yeah. So this is the approach that we are going to use. Let's say now we go on to 7. So when we move on to 7, 7 mod 5 is 2 and 7 mod 2 is 1. Okay. So just a second, guys. Yeah. So 7 mod 2 is 1. So what values of aj should be satisfied? It should be 3, 1. Is there a 3, 1 here? No, in the map it is not there. So my answer remains 0. And for 2, 1, it will be given as 1. Now we move on to 4. Okay. 4, 4 mod 5 is 4. And 4 mod 2 is 0. So what values of aj mod x and aj mod y should satisfy the problem? Tell me, guys. Do you get the idea? Like we are using a map, okay? And using that map, we just want to count the number of pairs that satisfy the problem, that satisfy the condition. Now, currently, none of them satisfy, but if you do it actually, it will end up working. If you guys have a problem in this, right? If you don't understand how two-sum works, I will explain it to you. It will become a detailed video. It will go for around more 10-15 minutes, but just wait after the post-contest discussion. I'll explain the entire how two-sum basically works. But if you guys know two-sum, this is just two-sum based on those two conditions. Is the problem clear? Is the approach clear? Yes? Great. So the code is as follows, that you just maintain a map of pairs and comma int, okay? And I iterate over every element of A. What should be the x mod? It should be x minus I mod x. And what should be aj mod y? It should be just I mod y. So answer plus equal to x mod comma y mod. Basically all the elements that before this element, that when you mod them with x, you get x mod, and when you mod them with y, you get y mod. And in the end, I will just add this element into my map. So map of I mod x, comma, I mod y plus plus. And in the end, I will just print out answer. Is the solution also clear, guys? Put a yes in the chat if it is clear. If you have any doubts, feel free to ask them. Okay.
Hello.
Raj asks, a map stores keys in sorted orders. How does it? Yeah. So basically a comparator for a pair works like this. The first element is given, the dot first element is given preference. So if there is 2 comma 3 and 1 comma 3, 1 comma 3 will be stored first. But if the dot first is the same, for example 1 comma 3 and 1 comma 5, in this case 1 comma 3 will be stored first and 1 comma 5 will be stored later. Raj, I hope this clears your doubt. Now with this question, this was a very interesting question, right? Because it involved math, and for me math is very, very interesting. Like, if you guys weren't able to solve the problem that you could have faced is you probably didn't write this on paper, and so on and so forth. Devraj wants to ask something. Devraj, if it is related to this particular problem, you can ask it in the chat. Otherwise,
Yeah,
if it's a general doubt, you can ask it at the end of the PCT.
yeah, it's related to this question only because when I read the problem statement, I was thinking about GCD or something because it's a math related problem, right? But
Yeah.
how do you think about the equations and all that thing?
Yes. So again, this is actually related to thinking, right? So can we take this at the end of the PCD?
Yeah, sure, sure.
Okay, thank you. So we have covered problems A, B, C, D. Now let's move on to problem E. So wow, Anna and Valentine's Day gift, and this reminds me that tomorrow is Valentine's Day. So happy Valentine's Day, guys. Right? Yeah. So what does the problem say? On Anna's turn, what does she do? She takes an element and she reverses the digits. Okay. And on Sasha's turn, what does she do? She takes any two elements and she concatenates them in any order. Okay. And in the end, we have to print if the number with optimal play, if the number is greater than equal to 10 raised to m, then Sasha wins. Otherwise, Anna wins. So what does the problem state? There is an array of elements, okay? A1, A2, A3, so on and so forth. Anna and Sasha play a game. So Anna and Sasha play a game. And what do they want to do? Anna starts first and then followed by Sasha. And the game is continued till there is exactly one element in the array. It stops, right? So when it is Anna's turn, she takes any two element, she takes any one element and reverses it. What does this mean? If it is 97, it becomes 79. If it is 1, 2, 3, 1, 2, 3, 4, 5, it becomes 5, 4, 3, 2, 1. Okay. But if it is, let's say 100, then it becomes 1 because it is 0, 0, 1. And if we remove these zeros which have no value, it becomes 1. So this is what Anna does. And what does Sasha do? Sasha takes any two elements, AI, AJ, and concatenates them. For example, if it's 53 and 75, then she just concatenates them like a string. So she can either make it 7553 or she can make it 5375. She cannot change it, okay? Two elements, either do 75 plus 75 and then 53, or do 53 and 75. So what does Anna do? Again, Anna reverses and Sasha concatenates. Is this much clear, guys? Is the problem clear? Is till now? This is a very, very simple problem, okay? You guys must be thinking. Okay. Now, what does the problem ask? The problem asks that with optimal play, if the last element left, if it is greater than equal to 10 raised to m, then who wins? Then Sasha wins. If the final element is greater than equal to 10 raised to m, then Sasha wins. Now, guys, this is a very, very, very important property. Keep this in mind. What this basically means is that the final element should have m plus 1 digits. This is what this means. Now you might be asking how. How does this mean that? So let's have a look. Let's say we are looking at 10 raised to 1, which is basically 10. So what are the elements? It's 11, 12, 13, 100, 1, 2, okay, 17. So what does this mean? Any two-digit number or any number such that the number of digits is greater than equal to 2 or basically greater than equal to 1 plus 1 will always not with leading zeros, okay, not like something like 0, 0, 1. It should be a proper number. It will always be greater than equal to 10 because 10 is the smallest two-digit number, right? If you look at 100, 100 is the smallest three-digit number. If you look at 1000, 1000 is the smallest four-digit number. So if you can guarantee that the number of elements, at least, okay, I forgot to write at least here. If you can guarantee that the final element has at least m plus 1 digits, you can say that Sasha wins. Is this much clear, guys? Tell me. Is this much clear? Clear? What about others? There are quite a few people here, right? Is it clear for everyone? Great. So, if this is clear for everyone, okay, what did we observe now? Final element should have m plus 1 digits. Okay. This is what the problem asks. Now, what does Anna do? She reverses and Sasha concatenates. Now, guys, let's observe, okay? We know the array and we know the number of digits in each element, okay? Let's say we have 5, 17, 13, 100, 14, 15, 16. Okay. So if Sasha were to only do the operations, okay, Anna does not exist. What will she do? She will just concatenate this. Okay. And does order matter here? Order does not matter here, right? We discussed right now that number of digits matter. The number itself does not matter. The number itself does not matter. Okay. So if Sasha were to only play this game, she would just concatenate all these numbers. Okay. And what is the number of digits here? It's 1 plus 2 plus 2 plus 3 plus 2 plus 2 plus 2. So what is it? It is like 14, right? So here the number of digits is 14. So if M was 13, then Sasha would have won because the number of digits should be 13 plus 1. So if M was smaller than equal to 10 raised to 13, or if M was smaller than equal to 13, then Sasha would have won. Is this much clear, guys? Tell me, is this much clear? We are taking it step by step. Tell me if this much is clear. Put a yes in the chat, guys. What about others? Is it not clear? What is the issue? What about Suman? Clear? Great. So if this much is clear, what is Anna's job? Anna's job is to reduce the number of digits. And can Anna reduce the number of digits? Yes, she can. How will she reduce the number of digits, guys? Let's say there is 100. Can you reduce the number of digits here? Yes, you can convert 100 to 1. And now number of digits reduced by 2. So for a number, how many ever zeros you have, Anna will try to take the number with the largest number of zeros and then just reverse it. If there are x zeros in that number, then Anna will just remove it and then the number of digits reduced by x. Is this greedy approach clear, guys? Yes, the only ending zeros matter. Is this greedy approach of Anna clear? Like Anna will try to take the number with the largest number of ending zeros and then just reverse it. So all those ending zeros vanishes. And we right now discussed that only the number of digits matter. The number does not really matter. It's the number of digits. Tell me, guys. Put a yes in the chat if it is clear, or you can ask to re-explain. Right? Now, one more thing to notice is that, let's say if there is a number 500, okay? Anna does the operation once, makes it 5. Now, if she does any number of operations again, the number of digits does not decrease. So what does this mean? She will do an operation only once on an element, only once on an element. And what is Anna's greedy strategy? Pick element with most ending zeros and reverse it. Okay, this is Anna's strategy. Okay, so what should be Sasha's strategy? Anna is trying to remove all the zeros, and apart from zeros, Anna cannot do anything. So what should Sasha do? Sasha should try to stop this. Now, how will Sasha stop this? Let's say the elements are 10, 100, 1000. Okay, these are the elements. So Anna's strategy is simple. She will take the element with the largest number of ending zeros and just reverse it. So she'll take 1000 and she'll make it into 1. So the array is now 10, 100 and 1. If you leave it as it is, the next element that Anna is going to pick is 100. So we want to save these number of zeros, right? So to save these number of zeros, what do? We just concatenate this with any element. So the array becomes 10 and 101. And Sasha saved these two zeros. So what will Anna do now? She will take this element and make it 1. And then in the end, there is only 2 elements left. So Sasha will just do this. And this is the final answer. Is Sasha's strategy clear, guys? Tell me. Is Sasha's strategy clear? What will Sasha do? When it is her turn, she will see which number has the largest number of zeros, and then she will just concatenate some other number to it, so that all those zeros are protected and basically not used. Tell me, guys, is Sasha's strategy also clear? What was Anna's strategy? Just pick the element with the largest number of ending zeros and just reverse it. So all those digits are lost. All those zeros are lost. What is Sasha's strategy? She just takes the number on her turn. She just takes the number with the largest number of zeros and just concatenates it to some other element. Is this much clear, guys? Put a yes in the chat if it is clear. Yes. Devraj asked, but Sasha will look for another number with max digits, right? No, it does not matter. I'll tell you why. Because in the end, okay, if the array is like 1, 2, 3, 4, 5, okay, or 5, 5, 5, as we discussed, only the number of digits matter. Here, Anna cannot really uh, remove any digits, right? Whatever you do, the number of digits remain constant. So Sasha takes these two first, concatenates it, makes it 12, then take any other element, make it 4, then take 3, and then take 5, 5, 5. In the end, all the elements that didn't have 0, 0, 0 can just concatenate them. It doesn't really matter, right? So does the order really matter? Like if I took 5, 5, 5 first and then 4, the number of digits remain the same, right? So did the order really matter here? Tell me. Devraj, tell me. No, right? So the order does not really matter. You can take any other element and just concatenate it. Okay. So what did we notice? On Anna's turn, okay. On Anna's turn, she picks largest ending 0 batch and reverses it. On Sasha's turn, she does the same. She picks the largest ending 0 and concatenates it with some other number. So if you look at it, Anna picks the element with the largest number of zeros. Then Sasha picks the element with the second largest number of zeros. Then Anna picks the picks the element with the third largest number of ending zeros. Then Sasha again picks the element with the fourth largest number of ending zeros, and so on and so forth. So this is just the strategy, right? And in the end, we just have to check if the digit formed is greater than equal to m plus 1. Is this much clear, guys? Is the strategy of both people clear? If the strategy of both people are clear, let's move on to the code and understand how to implement it. Like we got it, but can we really implement it using plus plus? No. We are competitive programmers. We just need math and then we can implement. So we know the number of digits that will be lost is the number of ending zeros, right? So for every element in the array, first I compute how many ending zeros are there. 10 denotes the number of ending zeros and digit is the number of digits apart from the ending zeros, because that digits will be constant. You cannot change those number of digits. But what can you change? The number of tens. So while the number is divisible by 10, basically there is a 0 in the end. I will just do 10 plus plus and I will divide I by 10. After this is done, keep in mind, after this is done, there will be no ending zeros in I. So while I is greater than 0, I will do digit plus plus and I divided by equal to 10. In the end, I am doing m minus equal to digit. Why am I doing m minus equal to digit? Is because this number of digits cannot be changed. Okay, we discussed that the number of digits matter and this number of digits cannot be changed. So now our new target is m minus digits, number of digits. and we have a vector which stores number of zeros of each element. So zeros dot pushback 10. Is this much clear, guys? Is this much clear? Tell me. Put a yes in the chat if this much is clear.
Sorry, I didn't get the code. Can you re-explain?
Yeah. So what didn't you get?
That for loop from like int 10 equal to 0, right? From that I
Yeah.
didn't get.
So in every number in the array, okay, we are counting how many ending zeros does it have, and apart from the ending zeros, how many digits does it have? Is this much clear till the while loop?
Yes, yes.
Okay. Now our target was to make our ending element with m plus 1 digits, right? Yes.
Yeah.
And apart from the ending zeros, I am sure that at least, like for example, uh, if the element is 5500, even if Anna, worst case, Anna takes these two zeros, the number of digits, I will at least have two digits, right, in my final answer.
Yes, got it.
So my new target is just m minus equal to digit. And now in my zeros vector, I just push back 10. Okay. Because that is the digits that can be actually manipulated by Anna. So in the end, I just sort zeros in descending order. And as we discussed, Anna takes the largest, Sasha takes the second largest, Anna takes the third largest, Sasha takes the fourth largest. So I'm starting from the second largest, and then I go to the fourth largest, sixth largest, and my target, I am reducing it by zeros I every time. In the end, if m is smaller than 0, instead of doing this, what you could have done is have a variable called n here, and then you could have done n plus equal to digit and n plus equal to zeros I. And then if n is greater than m, you can print Sasha, or else you can print Anna. But the concept is the same. What is the, like I'm checking the same thing in final element. Okay. Number of digits should be greater than m, or greater than equal to m plus 1. Is this much clear, guys? Tell me. Yes. Wasn't it a simple problem? Now that you know the solution, now that you know how to think about it, don't you think it was not that hard? Put a yes in the chat, guys. Come on. Yes, I am taking F right now. In the loop, why are we starting from 1? We are starting from 1 because we know what elements Sasha can save. So whatever element Sasha can save, I'm subtracting it from M, basically reducing my target. So Sasha can take the second largest, then the fourth largest. So that is why I start from second element, then fourth element, then sixth element. I take all those because Anna is obviously going to reduce the largest one, the third largest, the fifth largest. Basically, the for every eventh largest, Sasha can take it. Okay. So let's move on to problem F. Problem F is actually very, very simple. Like it's like if you know one topic, okay, I will give you the prerequisite. The prerequisite of this problem is just cycle detection in a graph. Okay. And if you know this much, we are going to know how it is beautifully applied in this problem. This is the prerequisite. Okay. You need to know how to detect a cycle in a directed graph. This is the prerequisite. Now, let's think about the problem. What does the problem say? The problem says that there were n people, and for every person, they took a screenshot. Okay. If for every person they took a screenshot, that person who took the screenshot is in the front. Okay. Apart from that person's screenshot, the relative order remains the same. Okay. Now we are asked, is it possible to form an array such that it satisfies all the screenshots given? Is the problem statement clear, guys? What does the problem statement say? There are n people and k screenshots. Okay. If there are k screenshots, if a person A took the screenshot, then he will be on the front, and apart from that, the relative or like the order will be given, whatever it was, right? The first element will be that person itself, and then whatever his screenshot was. What is our task? Our task is to know if it is possible to create an array or not. Okay. Is this much clear, guys? Noob is asking, I didn't get from the question, how do you know cycle? Yes, that is what I'm going to explain, right? That is what I'm going to explain. But is this much clear? Is the problem clear? Yeah, okay. Now, if the problem is clear, let's take the first. I'm just explaining the problem, right? Devraj, whatever the problem asks. We have to, yeah, what do we have to do? We have to print yes if it is possible to, like, okay, I will give you an example. Okay, there was no explanation. Okay, I will tell you. Let's take this. Okay, let me just write it down. 1 2 3 4 2 3 1 4 2 1 4 3 4 2 3 1. Okay, so we know that the person who took the screenshot removed him from the list and put him on the top. We have to say if it is possible to create an array such that it satisfies all these screenshots. For example, here one could have been in the first position or the second position or the third position. Two could have been in the first position, so on and so forth, right? Is there a possible output or array such that it satisfies all of this? Like if you were to place this 1 2 3 4 wherever you wanted, is it possible? So I think 2 3 1 4 satisfies all of this, because I will just take this 4, put it here. I will take this 3, I will put it here. I will take this 2, I will keep it as it is, and I will take this 1 and I will put it here. So in the end, I have 2 3 1 4, which satisfies all the conditions. So this is what it is. We are asked, if it is possible, print yes, otherwise print no. Okay, is this much clear? Is the problem statement clear to everyone? Tell me, guys. Yes. Now the beautiful part of this problem. Okay, let me write this down. Okay, 1 2 3 4. What was it? 2 3 1 4. 3 2 1 4 4 2 3 1. Okay, if this is my arrays, okay, apart from this, like ignore this. Okay, ignore this. What do we know? We know that after 2 there should be a 3, after 3 there should be a 4. Okay, in this array. Now what does this array say? It says that after 3 there should be a 1, and after 1 there should be a 4. I'm indicate this arrow represents that. Let's say x comma y represents that. After, basically in the final array, after the position of after x should come y. Okay, This is a directed arrow. Okay, it does not go the other way. Okay, we process this. Now this. After 2 should come 1, and after 1 should come 4. Okay. After 2 should come 3, and after 3 should come 1. So this is what we have created. We have created a graph of the conditions given. Is this much clear, guys? We have created a graph of the conditions. Tell me, guys. Is this much clear? We know that after every element, what element should come. Not exactly next, but we know in the relative order it should be there. Okay. Now, we know that it is 2, 3, 4, and 1. Okay. So we have to create an ordering such that all of this is satisfied. Okay. So if we look at 2, 3, 1, 4, after is 2 coming after 1? Let me just erase this. Okay. Is 2 coming after 1? Yes, because 2 is the first element, 1 is the third element. Is 3 coming after 2? Yes. Is 4 coming after 3? Yes. Is 4 coming after 1? Yes. So if you look at this array, it satisfies all the conditions. Okay. Now there is a simple claim that we can make. Okay. And this claim comes from the concept of topological sort. Okay. Or topological ordering. Basically, if I had to order these elements, right, such that all these conditions are satisfied, how would I have done this? That is what topological ordering says. Now, I will tell you. If I create any graph, okay, 1, 3, 5, 2, 4, okay, 5, let's say 6, okay, 6. Now, I should also have 4, right? 4. So, can you create a valid this? Let me take a smaller example. Let me take after 1, there should be 2. After 2, there should be 4. After 1, there should be 3. And after 3, there should be 4. Is there a valid solution? Is there a valid ordering for this graph? Tell me, guys. Right? If you take 1, 2, 3, 4, does 1 come before 2? Yes. Does 2 come before 4? Yes. Does 1 come before 3? Yes. Does 3 come before 4? Yes. So this is valid. What is also valid? It is 1, 3, 2, 4. So basically, if you look at a particular path, okay, a particular path, that path should be in relative order. Now tell me, when would it not be possible? I will show you one more example. 1, 2, 4, 3, this. Now tell me, guys, is it possible to order this particular graph? Or is it possible to create a graph which satisfies these conditions? Tell me. No. Why is it not possible? Tell me, guys. Why is it not possible to order this? Yes, because there is a cycle here. If there is a cycle here, the path of the relative order is cyclic. So you can't really create a straight chain. Whereas what was the difference here? The chain is not cyclic, right? So I know after 1 comes 2, then 4. And after 1, there is 3 and then 4. But here, I don't know what comes first, because whatever comes first, there is something that is contradicting it. After 1, there should be 2. After 2, there should be 4. After 4, there should be 3. After 3, there should be 1. So it is not really possible. So what do we basically want to check? The graph which is created should not have a cycle. This is all that we need to check. So what are we doing? From all the arrays that we are given, we are constructing a graph, and after that we are just checking if the graph has a cycle. If this was not intuitive to you, it is fine, because there is a concept. Okay, after this PCD, do one thing. If you are not aware of this topic, read this. Okay, topological sorting. The essence of topological sorting is based on this fact that if you want to create an order like this, then the graph should not have a cycle. And we also intuitively proved it, right? That if there is a cycle, we won't ever be able to do it. It makes sense also. So is the idea clear for people who weren't able to solve it? That if there is a cycle in this graph, we won't be able to make an ordering. Tell me, guys, put a yes in the chat if you guys understood. Noob says yes, Ekam says yes, Devraj says yes. What about others? Okay, so that is what we exactly do. Cycle detection in a directed graph, it is a very standard algorithm, right? What do we basically do in this is that apart from your visited, you also have a DFS visited. Okay, why? Like it is a bit more difficult to check a cycle in a directed graph. In an undirected graph, okay, you can check if it is already visited, you say true or false, but in directed graph, you cannot do this. You have to have a DFS visited array as well. So what do we basically do? I take in the array, and for every element apart from the first, we can't take the first because that is pulled out, right? So we don't know about it yet. So for every element from from index 1 to index n-1, or from the second element to the last element, I make a graph, right, stating that aj minus 1 should come before aj. So basically, what does adjacency of x contain? All the elements that should come after x. Okay, I'm having a set here, but you could have a vector as well. I thought using a set would make it faster, but it is not necessarily it is not necessary. After that, I have a simple DFS call which checks if there is a graph or not, if there is a cycle or not. So, and I have a cycle variable which is given false. So for every node that is not visited, I just make a DFS call and I check if there is a graph or not, if there is a cycle or not. If there is a cycle, then the cycle becomes true. And in the end, if there is a cycle, I print that it is not possible. Otherwise, I print that it is possible. Is it clear, guys? Is it clear? It was a very beautiful problem that shows you how you can model a particular problem to something completely else and then solve it very simply. Like, the hardest part about this problem was to think that you can solve it with graphs. So is it clear? Put a yes in the chat if it is clear, guys. Noob says okay. What about others? Okay. So that was it for this post contest discussion. If you have any doubts, feel free to reach out to us on Discord. Thanks a lot for watching. Bye bye.